Okay, this solved example is related to the fins. We know that fins is normally used to increase the heat transfer area in the heat exchanger and increase the overall heat transfer performance. In this problem, we do a little bit kind of understanding. Okay, so we compare three materials: copper, Cu, aluminum, and stainless steel. Okay, used as a fins material. We know we are given that the convective heat transfer coefficient H, this guy, is equal to 25 watt per square meter Kelvin. The problem is evaluate the suitability of the fins, the iron-based fins, copper, aluminum, and stainless, means the three things, with the dimension of 10 centimeter long and 2 centimeter thick and 1 meter weight. Okay, so pick the best material by considering the effect of weight on the heat transfer. So we want it to be we want it to be Q as high as possible, so the efficiency of the fin as high as possible. That is number one. And number two is we want it to be light. We don't want our heat exchanger to be very heavy. Okay, so what we need to be doing here is that we need to find out first the properties of the fin materials, which is the heat conduction capacity K of that. So the K value we find from the property table, and the density of those materials. So we find out here. And what we do next is we want to see, because let's say we use aluminum as the reference. So what we do next is we need to find out the weight ratio. So weight ratio is given like what will be the relative weight of the three materials if they are the same volume. So then in that case we can compare the density. So basically one here for aluminum is obtained from, so we use the aluminum as the reference, so it's 280 divided by 280. Okay, and then for I will use for stainless steels, this one then equal to 855 divided by 280, and finally here is equal to 970 divided by 280. You see that copper and stainless steel is more than 3 times the weight of the aluminum. So the next one is we need to find out the efficiency of the heat transfer. So if you look there, this is the shape of the fins, and then with this regular shape we can use the equation to find out what is the efficiency. Yeah, but before that we need to find out what is the perimeter of the fins is given. So px is actually here, perimeter of the fin, ax is actually cross-section area of the fin, and L is the effective length of the fin. So we can use the equation for this particular fins. Remember, different fins will come up with different equation, and there is and we can actually calculate the efficiency of the fins using the graph. And by inserting the above value, we can find, because it's a function of h. Okay, so it's okay, we need to find out m and l. L is a function of geometry of the fin. M is function of h, which is convective, so it's the same for all three. Px also the same for all three. K we have to adjust based on the properties of the material, and ax is the same for all three, and we end up with this value. So we have efficiency of the fins for copper, aluminum, and stainless steel. And then we do also the same. We look, we use aluminum as the base. In this case, one here we obtain from 0.943 divided by the reference, which is itself 0.943. So you see here on the top for copper, we have Q actually better relative to the aluminum. So we have Q of 1.033 relative to 1 for aluminum, and for the stainless steel is slightly less, which is 0.687. It is quite understandable because of it has slightly much lower conduction capacity. Lastly, since we need to take into account the weight of the material, we also use the relative value. What we do here is we also use the aluminum as the as the reference. So here is what we use is we introduce new parameter, which is Q that we just calculate, divided by the weight ratio. So 0.298 here was obtained from 1.033 divided by the weight ratio that is 3.464. We end up with 0.298. Then this is 0.225. This is actually equal to 0.687 divided by the W there, 3.053. So based on this one, we know that the weight on the effect of weight on heat transfer, which is represented by Q of W, is the highest for aluminum. So based on this basic assessment, we know that aluminum is the out of the three, aluminum is the best material for fins.